Let's take a look at section 11.5, probability with fundamental counting principle, permutations and combinations. Uh, Letter A starts with, please change your numbers from 5 and 1 to 3 and 3 so that the question at the end makes more sense. 3 men and 3 women line up in a checkout counter in a store. Now, typically, the question will go from giving you the scenario right to this last question down here. Find the probability that the first person in line is a woman and the line alternates by gender. You won't necessarily have, um, in between questions to guide you to the answer. All right, but let's see how you can get yourself to ask these questions. So what are they asking? They're asking to find the probability, right, of something occurring. So we know that we're looking for two numbers, the number of the outcomes, right, our numerator, over the total number of possibilities. So typically the total number of possibilities is a little easier for people to find, right? Because you don't have to look at all the different counting techniques. Let's look at this question again. 3 men and 3 women line up in a checkout counter in a store. So the first question asks, in how many ways can they line up, right? In how many ways can 3 men and 3 women line up at a checkout counter in a store, right? So if you can picture it, a lot of times I try to picture it, right? So we have male, 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 right? And then we'll have female, female, female. So if I had all these people, right, move around, in how many different ways could they line up is the first question. And that's going to be the total number, right? That's going to be our denominator, total number of possibilities. And so one way to do this is with fundamental counting principles to count the permutations, because we do know that order matters here, right? And so ask yourself, in the first position, right, how many choices do we have? Well, we have 3 men and 3 women, so we have a total of 6 choices. Once that first position is filled, how many choices for the second, right? And we know that that would be 5. Right? We're going to multiply these together and so on. Fill in your chart. In the third position, right? We've chosen the first 2. That leaves us with 4. The fourth position, fifth position, and sixth position, right? And we're going to be left with 3, 2, 1. And so this is the same as taking a permutation, right, of 6 things, and we're choosing 6. And the total number here is going to be 720, right? So that's the total number of possibilities. Now, here is the question that is going to involve finding your numerator. In how many ways can they line up if the first person in line is a woman and then alternates by gender? Woman, man, and so on. Right? So let's look at these same positions again. Okay, we know order matters, right? And so let's see. First position, right? They tell us that it is a woman. Look at our little picture up here. How many women are there? There are 3 women, so we have 3 people to choose from. Now our second position says that it's a man, right? And so how many men do I have to choose from? Right? Go back to our picture. I have 3 men to choose from. In our third position, it's a female again, and I've already chosen one. So how many are left? 2. And we know the fourth position is a male, right? And we've already chosen one of the 3, so that leaves 2 left. And that leaves us with the fifth and sixth position. There's only one female to choose from and one male to choose from, right? So how many ways can this happen? If we multiply those all together, we are at 36 ways, right? And so questions in the first 2 parts broke up what we would essentially have to do on our own in part 3. Find the probability that the first person is a woman, and then the line alternates by gender, right? So the probability of alternating by gender is going to be, right? What are the total possibilities for that? That was at 36 over, right, the total number of ways they can line up when we're just looking at 3 men and 3 women. That was 720, right? So the probability of the event is going to be the number of the event, right, 36, over the number of total outcomes, 720. When you put that in lowest terms, divide both by 36, we are 1 out of 20. Alrighty, let's look at the next problem. A club consists of 5 men and 7 women. 3 members are selected at random to attend a conference. Okay, so let's look at this again. I have 5 men, 1, 2, 3, 4, 5. And I have 7 women, 3, 4, 5, 6, 7. And I just do this for me so I can just go back and, picture it without it being so wordy. And so what's going to happen here? We are going to pick 3 members are selected at random to attend a conference, right? So we're going to, right, pick 3. And they get to attend the conference. So remember, typically you'll go right to this question down here. Find the probability that the selected group consists of 3 men. Okay, but let's split it up. First, in how many ways can 3 members be selected at random? Right, so this is going to be the denominator, the total number of possibilities. How many ways can I pick 3? Well, does order matter when we're just picking 3 to attend the conference? No, it doesn't, right? So we know that that's a combination. And there's a combination of what? How many do I have here? I have the 5 men and the 7 women. I have 12, and I'm choosing 3, right? So a combination of 12, choose 3, and you can put that in your calculator or use your formula. And we have 220 possible ways that 3 can be selected to choose to go to that conference. Now, find the probability that the selected group consists of men. So the very first question you should ask yourself is, right, how many ways can 3 men be selected, right? So how many ways can 3 men be selected? Well, here's my group of men, right? There are 5 of them. Does order matter when I'm picking the men? No, right? I'm just picking them. So we know it's a combination. And how many are there? There are 5 men, and I'm choosing 3. right? So use your combination formula or go ahead and use your calculator here. How many ways can this happen? There are 10 ways this can happen. So, right, the number of ways the event can happen is 10 out of the total number of possibilities, 220, gives us the answer to the question, right? Find the probability that the group is 3 men. Right? So we know that it's 10 out of 220, the total. And when we put that in lowest terms, we are at 1 out of 22. Right? So the trick here is kind of breaking them down, looking at the total number of possibilities, and then the number of possibilities for the event they are asking for. Alrighty, let's keep going. Letter C, we have 7 performers. A, B, C, D, E, F, G are to appear in a fundraiser. Okay, so the order of the performance is determined by random selection. How many ways can the performers line up? Right, so that is going to be the total. We know that is going to be the denominator. And then we're asked to find the probability of the following, right? 4 different things here. So, in how many ways can the performers line up? Well, you can do fundamental counting principle here, right? 7, 6, 5, 4, 3, 2, 1, right? That was because there was A, B, C, D, E, F, and G. 7. Okay, so we can get rid of our last thing here. And so that is the same as 7 factorial. And our denominator is going to be 5,040, right? The total number of observed occurrences, right? How many ways can this happen? Find the probability that D will perform first. Okay, so I have the 7 slots, and we want D first. Well, how many ways can I choose D? 1 way. Okay, so this is the 2nd position, 3rd position, 4th position, and so on, right? 5th, 6th, and 7th. And so now that D has gone first, how many choices do I have left for the 2nd position? And that would be 6. How many choices for the 3rd position? That would be 4, and so on. 3rd position, 4 choices left. 4th position, 3, 2, and 1. So the probability that D will perform first right? When we multiply these together, you should get 6 factorial, which is 720. And so D performing first can happen 720 ways out of the total number of ways they can line up, 5,040. And our answer here would be 1 out of 7. Okay, let's look at it again. Same 7 performers. Okay, this time, let's see, what do we have? E will perform 6th, right? So this is the 6th position, and it's definitely going to be E. And B will perform last. This is the 7th position. B will perform last. Well, if E is definitely this position, there's only one choice for E, right? And if B is definitely the last position, there's only one choice for B, okay? That leaves us with the rest, right? First position, I'm only going to be left with how many choices? 5. And second position, right, will leave us with 4. Third position, 3. Fourth position, 2. And fifth position, 1. This is the same as 5 factorial, right? And so we have 1020 here, right? 1020 ways that this can happen with E and B performing last. What was the total number of ways? The total number of ways was 5040. That's still our denominator. And let's see, 102 divided by 504, right, is going to give us about how much? And that's going to be, and so here we are at simplifying this, and that will give us 17 over 84, right? So they perform in the following order. Now that we're being asked about a specific order. So see if you can set this up. Give yourself the 7 positions, right? And here is the conditions, right? In the first position, you have to choose C. In the second position, you have to choose D. Third, B. Fourth, A. Fifth, G. Sixth, F. And seventh, E, right? So how many choices you have if C has to be your only choice? That would be 1. How many choices do you have if D is your only choice? That would be 1. And that will carry through to the rest of these, right? So for this specific order, there's only one possibility, and that's going to be 1 out of the total number of combinations, right? And we're at 1,000, I'm sorry, 1 out of 5,040. Okay, the last one, F or G will perform first. Here's the 7 positions, right? So this is first position, and it's going to be F or G, right? So then we go on second position, third position, all the way to 7th, right? So if you have F or G in the first position, how many choices do you have? You have 2 choices. Once you've put one of those there, how many choices do you have for the second position? Well, you've taken 1 out of the game, right? So you're left with 6. And then we will go down and put in the rest of our numbers in for the second through the 7th position, and that leaves us at 1,440, right? And we know that is the numerator for our denominator out of the total number of combinations, 5,040.